Alrighties, hello everyone, welcome to your pre-lesson video on exponential and logarithmic equations. We have a bit to cover today, so let's get started right ahead. Alright, so first thing we're going to look is how we're going to convert between logarithmic and exponential form. So they go back and forth with each other, and it's pretty handy to know how to convert from logarithmic form to exponential form and vice versa. Alright. So if we look at the formula right over here, right, we have log base b y equals x, and when you transform it to an exponential, it'll become y equals b to the power of x. Now, my trick here is if you're trying to transform it from logarithmic to exponential, you're going to look at this. Y is going to stay the same. It's going to stay in the same place as it is. B is going to get bumped up to the other side of the equation, and x will get bumped up to become the exponent. All right, so now let's take a look at that when we are practicing, right? So let's look. We have log base 3, 9 equals 2. From here, let's write out the equation. I want it. Remember, we have log base b y equals x. Right? I want to bump the b up to here, and then the x becomes the exponent. Y will stay where it is. So let's list out. I know my y is going to be 9, my b is 3, and my x is 2. When I want to write it as an exponential, I'm going to write it as y equals b to the power of x. Okay? So if I plug that all in, I have 9 equals 3 to the power of 2. All right. So see how b here gets bumped up. The x becomes the exponent, and y stays the same as it is. Now let's look at the next one. We have log base 6 square root 6 equals half. All right. So again, let's write out. We remember we have log base b y equals x. When we transform it into an exponent, it becomes y equals b to the power of x. All right, so again, I know my y is square root 6, my b is 6, and my x is half. So if I were to rewrite this into an exponential form, it will be square root 6 equals 6 to the power of half. All right. Now let's look on the other side of it, where we're transforming from an exponential equation into its logarithmic form. All right, so same thing. Now instead of bumping the things up, we want to bump it down. So to know which one you're going to be bumping down, you're going to take the terms that have the exponent. So in this case, the first one that we have, right, it's 2 cubed equals 8. So we write that in exponential form. It's b to the power of x equals y. And we know that when we're writing our logarithmic form, we want it as log base b y equals x. All right, so that means from here, again, I know my y is going to be 8, my b is going to be 2, and my x is going to be 3. So if I were to rewrite it into logarithmic form, I would then get log base 2, 8 equals 3. All right. Now let's look at the next one. Ooh, we have a negative exponent and a fraction on the other side. But no worries, we're going to do it like normal, like usual. So we have, again, b to the power of x equals y. And when we write it in logarithmic form, we again want it as log base b y equals x. Now if I were to, again, list out the things, my y is going to be 1 over 10,000. My b is going to be 10, and my x is going to be negative 4. Therefore, if I were to write this into logarithmic form, I would get log base 10, 1 over 10,000 equals to negative 4. And that'll be it. All right. Now on to the next thing. So with logarithm, we have some rules and properties that we must remember. So we're gonna go over that right now. All right. So for the first one, we have when log base b x to the power of a. So if you can see here, the exponent a here, will be written at the side of the log, right? So whenever we have an exponent in a logarithm, we can just write it to the side of it. All right, so we'll actually take a look at how this is done in some of these practice questions that we have at the bottom. But let's slowly go through all these rules first. All right, so now on to the next rule where it's log base b x times y, right? So whenever you see a multiplication like this, you can essentially break it down into them adding. So it's log base b x plus log base b y. All right. Now, if your log is dividing with each other, like in this case, log base b x over y, or x divided by y, you can rewrite it as log base b x minus log base b y. All right. So especially these three, actually, these few are very handy to remember. All right. Now let's look. We have log base b x. Now we need to change the base formula, right? This is what you would do. You would pick a number here for c. So normally, generally, people will either take log base 10 or ln when they're changing bases, just because that is a value that you can put into the calculator. All right. Now you're going to change the bases. The one that is here, like in the case of x, that's in the x spot, will be on top. So if log base cx divided by log base cb, right? So x will go on top, like right here, and b will go to the bottom. Can you see that? All right. Now let's look. Log base b would equal to 1. So if, let's say, for example, I have log base 3, I immediately know that's 1. So whenever your base and the number here is the same, then it will equal to 1. All right. Now same thing here. Look, log base b to the power of x. This x technically, right, would go to the side. And then we straight away know that log base BB would equal to x, right? Because log base BB is equal to 1. All right? Now for the next one, log base B1, right? So whenever we have a 1 here, we straight away know that our log is going to equal to 0. No, without a doubt. You could have like log 3000, 1, straight away know that this is going to be 0. Like I said, this is 1, immediately this is 0. All right. Now the next one, log base b0 is undefined. So whenever you see a 0 right over here, straight away just put it as undefined because you just mathematically is impossible. All right. Now for the next one, we have log base b c. So if we were to flip it, right, or inverse it, where the b and the c will exchange places. So as you can see, if we flip it upside down, we get 1 over c base c b. See how here is log base b c. Now if you flip it upside down, it'll be 1 over log base c b. All right. Now on to the next one. So whenever you have a base e, like in this case log base e, right, we can write that simply as ln, which stands for natural logarithm. So whenever you see log base e, just write it as ln. That's all. It's just a special thing. Now ln e would equal to 1, right? Because it's like log base e. Same thing, right? Because remember, ln is essentially log base e. So it's log base e. That's why these two are the same. All right? Now let's move on to practicing the questions. Let's look at the first one. So we have log base 7, 343. It gives me a clue on how to solve it by looking at the base. All right, it's going to be related to 343. And when I find out, I know that 343 is 7 cubed. So if I were to rewrite this equation, it will be log base 7, 7 cubed. Oh, look, an exponent. Because there's an exponent, I'm going to write it to the side of my log. Can you see that? And now look, ooh, we have log base 7, 7. And I straight away know that this is going to equal to 1. So that means 3 times 1, right? That means I'll get my final answer, 3. All right? So that's how we would use the rules and properties of logarithms. Now on to the next one. We have log base 5, 1. Immediately I know this is going to be 0 because of the 1 that's here. Remember, it's a given. If it's a 1, it will immediately equal to 0. Okay. Now for the next question. Ooh, look, we have log base 49, 7. All right. I know that 49 and 7 are related to each other. So what I'm going to do for this case is I'm going to flip it upside down. And when I flip it upside down, I know my 49 and 7 are going to switch places. So now I'm going to have 1 over log base 7, 49, which means I can rewrite this as 1 over log base 7, 7 squared. I have an exponent, right? So that means I'm going to write the exponent at the side of the log. So I have 1 over 2 log base 7, 7. Again, I know 7 log base 7, 7 is going to equal to 1. Therefore, I will get my final answer of half. All right? Now on to the next question. So we have now log base 64 and 1/4. Now the thing with bases is that it has to be 2 or more. It can't be lower than 2. There's no such thing as a log base 1. So therefore, this time I can't flip it upside down because that will give me a log base 1/4, which is not possible. So for this case, I am going to change the basis, not by flipping it, but by using this rule. All right. So when I do that, I know that 1 over 4 and 64, they're both related to the base 4. So I'm going to put everything to the base of 4. So I'm going to get log base 4, 1 over 4, divided by log base 4, 64. Now from here, I'm going to see how they relate. Okay, so I know log base 4, 1 over 4 is equivalent to 4 to the power of negative 1. So I'm going to write it as that. Over log base 4, and I know 64 is 4 cubed. So I'm just going to rewrite as that. Okay. Now I am going to rewrite this as with the exponent on the side. So I have negative log base 4, 4 over 3 log base 4, 4. Oh, look. Log base 4, 4. That means these two would equal to 1, right? So in the end, I will get my final answer of negative 1 over 3. All right. If you have any questions about this, bring it to your deep dive lesson. Yes. Now this is another property that is under logarithms also. Let's see. So we have, well, it's more of an exponential. So we have b to the power of log base b y. Essentially, your solution would equal to just y. All right. So let's look at this question. We have 12 to the power of log base 1244. Straight away, I know because if we were to label this, this is b, this is b, this is y. That means I need my answer to be y. All right. So that means 12 to the power of log base 1244 would equal to 144. All right. Now, if you have any questions about this, send me a message or bring it to your deep dive lesson. On to the next thing. So now we're going to learn how to evaluate logarithms by condensing or expanding it, which is pretty helpful at times depending on the question that you have, because sometimes you would need to condense it together, which means you're going to put it into a single logarithm. Sometimes you need to expand it, which means you're going to need to break it up into more, right? So we're just going to practice a bit on how to do that using the rules and properties that we learned before, right? So let's look. We have log to the power, we have log 6 times 11. And now from that, I know it's going to be using this rule, this property. So that means they're going to be adding, all right? So if I'm going to break it up, it's going to be log 6 plus log 11. There we go. Oh, and by the way, if let's say you don't see a number down here, right? And it is automatically known that the base is 10. So you don't even need to write it if the base is 10. But if it's other numbers like 4, 3, 2, 5, you do need to write the base number here. But if it's 10, you can just simply write it as log. All right? All right, on to the next question. So now we have log base 3, 6 over 11 to the 5th. So first thing I'm going to do is distribute the power, but not multiply it. So I have log base 3, 6 to the power of 5, 11 to the power of 5. Now, because these are dividing with each other, that means I know that they're going to be subtracting if I am expanding it. All right. So when I write it out, it's going to be log base 3, 6 to the power of 5. The one that is on top will always be on the left side. Okay, that one's very important to remember. Minus log base 3, 11 to the power of 5. Now, because we have exponents, we're going to finally write them to the side. So our final answer is going to be 5 log base 3, 6 minus 5 log base 3, 11. And that'll be it. All right. Now let's look at the next one. As you can see, the cube is only associated with the number 2, right? So that means when we write out this, when we expand this logarithm, this 3 here will not have a cube because this cube is only associated with the 2. So that means when we expand it, it's going to look like this. It's going to be log 3 plus log 2 cube. We have an exponent, so we're going to write it to the side, right? And then since this has nothing left, we're just going to leave it as it is. So our final thing is going to be log 3 plus 3 log 2. All right? And that's how you expand. Now we're going to go into condensing, where we're going to put it into a single logarithm. So let's look. Minus, when it is subtracting, that means I am going to divide the logarithms, or at least the numbers here are going to be divided with each other. The number that's on the left will be on top, and the number that's on the right will be at the bottom of the fraction. So if I were to write it as a single logarithm, it will be log 3 over 8. And that is it. See how this 3 is at the top and the 8 is at the bottom. So on the left, top, right, bottom. Okay. Now for the next one, we have log 6 over 3. If I were to rewrite this, I would have 1/3 log 6. Now because this is to the side, that means if I were to condense it to a single logarithm, I'm going to put it up here as the exponent. All right, so I would finally get log 6 to the power of 1/3. All right. And now we look at this one. We have log 2 plus log 11 plus log 7. Because they are adding with each other based on the properties, right? They're going to be multiplying. So if I were to rewrite this, it would be log 2 times 11 times 7. I can do that, right? So 2 times 11 times 7, which would finally give me as log 154. All right. And that's how you condense logarithms. Now we have a few more practice problems before we learn how to solve logarithmic and exponential equations. All right. So for this one, the first thing I want to do is bring the exponents up, right? So numbers on the side will become exponents. So first step I'm going to do is log base 3 u to the power 6 plus log base 3 v to the power of, to the power of 6. Okay. Now because it's adding, that means these are going to be multiplying with each other, right? So I'm going to get log base 3 u6 v6. We can leave the final answer like this, or because I know that these two exponents are the same, I can also write it as this, log base 3 u v to the power of 6. All right? So if you write it as either or, this will be correct. Now let's look at the next thing. We have log base 5, 4 plus log base 2, 7. If you notice, the bases are different. And because the bases are different, we cannot actually combine them into a single logarithm. It would simply just be log base 5, 4 plus log base 2, 7. And this is as simple as can go, all right? Because they have different bases. So you got to remember, you got to watch out. If the bases are different, you cannot condense them together. If you notice the previous ones, look, base 3, same, you can combine them. Base 10, base 10, base 10, same, can combine them. Base 10, same, combine, all right? Base 5, base 2, different, can't do anything. All right? If you have any questions about expanding and condensing logarithmic equations, send me a message or bring it to your deep dive lesson. All right, now on to solving logarithmic equations. So we are going to solve for x. So it takes a lot of practice when solving logarithmic equations, but I'm going to show you a few questions on how you're going to solve them. So for this one, we have log base 5, 2x plus 3 equals 2. What I want to do in this case here is, because my x is right here, I want to transform this into an exponential function, right? So remember, for exponential functions, this one here would stay where it is. The base will get bumped up, and the 2 will get bumped up as the exponent. So if we were to rewrite this, we would get 2x plus 3 equals to 5 squared. All right, and then we know 5 squared is going to give us 25. Now we want to isolate 2x, so we're going to subtract 3 on both sides of the equation to give us 2x equals 22. I want to isolate x, so I'm going to divide both sides by x. I'm going to divide both sides by 2 to finally give me x equals 11. And this is the solution. All right, so if your x is here, you want to change this into an exponential function. Now let's look at this one. What are we going to do? Same thing like before, because our x is here, it's not a base, it's the y, right? We want to change this into an exponential. Now remember, ln is equivalent to log base e. So that means our base is e, right? So if we were to transform this into an exponential, 1 over x is going to be our y. So we're going to write it as it is. Our base is e, so we're going to bump it up. And our 4 will become the exponential. Okay? Now from here, I want to multiply both sides with x, so I can get rid of the function, right? So I'm going to get y equals x e to the power of 4. I want x by itself, so I'm going to divide both sides by e to the power of 4 to finally give me x equals 1 over e to the power of 4. And that'll be my final answer. Now you can just leave it as e, which generally is what the answer gives you as. There is a specific value that e has if you put it in a calculator, but like I said, you can just leave this as e. All right. Now let's look at this one. We have log square root x plus log x equals 2. Now the first thing I want to do is get rid of the square root. Now if you remember about your exponential, your rational exponents, there we go, and how you can transform this, right? Radical to exponential, to rational exponents. That would be equivalent to, so we're going to get log x to the power of half, right? Because square root, if we transform it into a rational exponent, it's going to be half. Plus log x equals 2. Now because these are adding, that means these are going to be multiplying with each other. So if we were to rewrite it, it will be log x to the power of half times x equals 2. Now based on the product rule, my exponents are going to be adding with each other. So this will then give me log x to the power of 3 over 2 equals 2. Now I have an exponent, right? Because there's an exponent, I'm going to write it to the side of my log. So I'm going to get 3 over 2 log x equals 2. Now I want to get rid of this, right? I want log x to be isolated. So I'm going to multiply both sides by 2 over 3. Which would then give me log x equals 4 over 3. Now, because I know my x here is alone, right, and the base is 10, I want to transform this into an exponential, right? So x is going to stay where it is. The base, which is 10, is going to get bumped up. And my 4 over 3 is going to get bumped up as an exponent. So now we're going to get x equals 10 to the power of 4 over 3. Now, remember with your rational exponents, you can write this in radical form also, which would be x equals cube root 3 10 to the power of 4. Remember, I can also simplify this because of the numbers here. So if I were to do this, I would get, because there's 1 here, that means I know I'm going to write 10 once, because 10 to the power of 1 is 10. Cube root 10, because I have a remainder of 10, so it makes 10 to the power of 1 inside the cube root. Alright, so this would be my final answer. If you have any questions about this, bring it to your deep dive lesson. Alright. Now, we are going to deal with exponential equations, and then you would change the base a bit more with exponential functions, with exponential equations, alright? So first one we have is 5 to the power of x equals 2. I'm going to transform this into a logarithmic function, right? So that means, again, if you want to decide, if you want to know which one is going to get bumped down, you're going to have to look at the one that has the exponent. So in this case, 5 is going to get bumped down to become the base, and x will be bumped down. Okay? So once we bump everything down, we're going to get log base 5, 2 equals x. Right? Because you can't put this into a calculator. If you notice in your calculator, you didn't have log, which is essentially log to the base of 10. So if we want to really completely write this, we're going to change the bases in terms of base 10. So we're going to have log 2 over log 5, and that'll be your final answer, right? Because remember, this one will be on top, the base will get the bottom. So if we change the bases, it'll be log 2 over log 5, and that'll be it. Alright, now for your next question, we have 5 to the power of x minus 3 plus 2 equals 8. The first thing I want to do before I can even transform it into a logarithmic function is to get rid of the 2, because we want 5 to the power of whatever to be by itself on one side of the equation, right? But now it's combined with 2, so we need to get rid of the 2. So to get rid of the 2, we're going to subtract both sides of the equation with 2 to give us 5 to the power of x minus 3 equals 6. Now I can transform this into a logarithmic function, right? So again, 5 is going to get bumped down to become the base, and x minus 3 is going to get bumped down. So we are then going to get x minus 3 equals to log base 5, 6. Alright. Again, I want this. If I need to plug in a calculator, I'm going to change it either into log or ln. So in this case, I want to use ln. So if I were to change bases, I'll get x minus 3 equals to this 6 is going to be on top, so it's going to be ln 6. 5 is the base, so it's going to get at the bottom, so ln 5. You see that? Now, x is not by itself. We want to isolate x now, right? But we have negative 3. So to get rid of the negative 3, we're going to add 3 to both sides of the equation. So our final answer is going to be x equals to ln 6 over ln 5 plus 3. And that'll be it. Okay? Now onto another one that looks a little bit complicated, but not really. So now we are dealing with fractions. And again, as I always say, when we have fractions, let's get rid of the fractions, right? So in this case, what we could do is we can cross multiply both sides of the equation. When we cross multiply, we're going to get 2e to the power of 2x equals to 3 plus e to the power of 2x. Oh, look. And then if you notice, these two, because they are e to the power of 2x, e to the power of 2x, these are like terms. So we are going to subtract both sides of the equation with e to the power of 2x. Okay? Now this is going to give us e to the power of 2x equals 3. Can you see that? Because, 2 minus 1 equals 1. Okay? Now that these are alone, what we could also do, right, is we're going to put ln on both sides of the equation. So I'm just going to literally just add ln. So it'll be ln e to the power of 2x equals to ln 3. Now the reason I'm using ln is because this is e. Just if you see e, just use ln. That's all. Okay? Now we have ln e to the power of 2x equals ln 3. Exponent. Let's put it to the side. So then we're going to get 2x ln e equals ln 3. Oh, look, ln e. I straight away know ln e is going to be equivalent to 1, right? So I would have 2x equals ln 3. Now on x by itself, so I need to get rid of the 2. And to get rid of the 2, I need to divide both sides of the equation by 2, right? So that means my final answer is going to be x equals to ln 3 over 2. And that'll be it. Alright, if you have any questions about that, again, as usual, bring it to your deep dive lesson or send me a message. Alright, on to your last thing of the day. Exponential growth and decay. So with growth and decay, essentially it can be a linear growth or decay, as you can see. It's a straight line, right, if it's linear, or if it's exponential, it is curved. Now with exponential growth and decay, they generally would, as you can see, they are very close to 0, y equals 0, but it will never touch y equals 0 for the most part. Sometimes, very rarely, but they're very, very close to y equals 0. Okay? Now, we won't go through some of the practice problems just because it is a little bit tedious. We will go through that during your deep dive lesson. Now, examples of questions that would have like these exponential growth and decay or linear growth and decay questions are such as those asking about like interest rates, growth of bacteria, or decay rate of a radioactive isotopes. Those are the really common ones where you will see questions asking you about exponential growth and decay especially. Alright? Now we look here, just quick recap. If you notice, because it's a straight line, the linear growth would have your slope-intercept form, which is y equals mx plus b. Alright, so remember b is like your starting amount, right, because it's your y-intercept. And then m is the amount added or subtracted each time x is increases by 1. Okay, it's your slope. You should remember that from your earlier topics. Now on to the newer stuff, which is exponential growth, right? The general form that's given is y equals ab to the power of x, where a is your y-intercept, which is also your initial amount that you're given, and b is the amount multiplied each time x increases by 1. And generally, this is the rate or percentage that you're given, and you're going to write it in term as a decimal. Okay, it's going to be expressed as a decimal. Now for exponential growth or decay over time, it is, as you can see, generally given by the equation, look, fx equals f0, right? Which means that this is essentially your initial amount. F0 is your initial amount, times y plus r. R is your rate, or your growth or decay rate expressed as a decimal. And as we do the practice questions in your deep dive lesson, I'll show you how you're going to write the rate, whether it's going to be a plus or a minus, depending if it's a growth or decay. All right. You want to write this as a decimal. So f of 0 times 1 plus r to the power of t. And t is the time, right, that you are given. Okay? And so if you have any questions about exponential growth and decay, like I said, we will be going over the practice questions during your deep dive lesson. But if not, yeah, we are done for today, guys. Right? As usual, if you have any questions on anything about exponential and logarithmic functions, send me a message or bring it to your deep dive lesson. All right? Thanks for tuning in. Have a good rest of your day.